All right, so the engine is assembled. Now I've got some old door skin and I'm gonna make a template of this engine. I've been reading up Quadrant's service technician training modules, and I need to figure out if my engine beds that are currently fiberglassed into the hull of the boat are gonna work for this engine. Now I have 3 mounts on the side of the engine and I can choose 2 out of 3. So there'll be some decision making there. But I also have some door skin, and we're going to make a template of the engine right now and draw that out, cut that out, and mark exactly where the engine mounts and the prop shaft are. Those are the most important bits, and then we can take it to the boat and see how it lines up with everything that's already there. We're back in the engine room, and I now have an engine in here. It may be made of plywood, but hey, it's a start. So this is the pattern of my engine. This will give me an idea of where everything's going to fit. One of the things I've done is strung up these struts right here with a little bit of support at exactly where the engine mounts, the base of the engine mounts will sit. Now I've got new engine mounts coming in the mail, but they're pretty much identical to the ones that came out of here. A couple of bushings, 3300 series, I think was the right call for these ones. But the beds were glassed in here, maybe for the original engine, most likely for that 4-cylinder that apparently was in this from the factory, but then they were modified for the Volvo TMD40, and now we have an SD33 going in here. All fairly different engines with fairly different mounting locations. So the forward mounts seem to ride on these previous beds pretty well. Now the alignment at the aft coupler here is a little difficult to gauge with just a plywood template, but the goal at this stage is not to get it absolutely perfect. The goal is to get it lined up and give myself some good mounting locations that I can then work up from, not down to. That's important. So I need to make sure that where these mounts want to sit, I can use the nuts that are on them to ram them up to like 1/2 inch or 3/4 of an inch, and that lets me level things out, and then I can get my feeler gauge back here at the coupler plate and really nail that perfectly. So right now I'm just trying to get ballpark first, and then we refine and we refine and we refine. So yeah, door skin is okay for now. Okay, one of my other issues is that this engine's actually narrower than the Volvo was. So I have a minimum clearance of 14 inches and a maximum of 21, meaning that ideally this engine mount ends up living right here. Now that's the one on the transmission. I do have spacers and I can stand it out another 2 inches, but it doesn't really matter to me much because, as you'll notice, there's no engine bed right here. It stops just before that. So I'm gonna have to mess with this anyways. So if I'm gonna have to make something new, I might as well make it to fit a little bit better. Oh God, I gotta measure this on the underside. Oh, that's annoying. That is quite the twist. Oh man. This episode is brought to you by Wattcycle, and they sent out their biggest and their smallest battery. We have an 8 amp hour 12 volt battery, and we have a 628 amp hour battery. Now, I wanted to compare the biggest to the smallest, mainly because I need a very, very small one for my dinghy. So I have currently a scooter starter battery, and it basically lasts an hour past sunset, and then that's pretty much it. So it'd be nice to get something that lasts a lot longer. And of course, the 628 amp hour, this is one of the craziest bulk deals available out there on the internet right now. Wattcycle's been taking the industry by storm. They got some basic smart features on this thing, but the real star is 628 amp hours. There's an incredible amount of power in a single battery. Mine arrived with some dents. Now that's not on Wattcycle. They packed it up really nicely. There's a foam packing and everything, but this is a heavy battery. Obviously somebody dropped it at some point. So we're gonna rip up these void if warranty stickers and find out if anything's broken inside. Good durability test for this metal case. Well, obviously the case is warped a little bit. Let's see. Oh. Foam along the top here. There's nothing there. There's actually more space in this box. That's crazy. So yeah, it shouldn't have damaged anything because there's plenty of space. Tinned too, that's nice. A tinned bus bar. We'd love to see it. Get your fiberboard. Those are some big cells. Holy guacamole. So you have your overventing pockets there. All of these bus bar connections. These ones are soldered or welded on. These ones are bolted on with little lock nuts and lock glue. But as you can see, the battery itself only takes up about like 3/4 of the case. There's an air gap all the way around. And I don't see, and there's no foam insulation in there. That's just air gapped. So this whole inclusion here where the dent happened, it's no big deal. Like there's 3 inches there, 1 inch there. Lots of space. The BMS is really far away from that.
They've marked every bolt. They turned it down.
Torqued and marked every bolt.
These are hand done.
And they have a BMS controlling the pairs of cells. So it'd be 2 in parallel and 4 in series. So that's how that's done. Meaning that the signal wire here for the BMS is really small. They're not measuring each cell individually, they're measuring each pair of cells. Yeah, okay, so they got a temp sensor on each pair of cells here. And these bus bars are gigantic. So this battery is rated for a 300 amp discharge, meaning that you could put this in your boat and running 12 volt, you could have a 3600 watt inverter running off of this continuously. So you can have that max load, no problem. That's a pretty crazy amount of discharge. It has basically all in, we're looking at 8 kilowatt hours of energy in one battery. I've had quite a few at 5. I've never seen an 8. That's so much power. And it's crazy that it's 12 volt too. So yeah, these bus bars are taking a lot of juice. Looks like this bar here is bent too, eh? The support.
It does.
I think this whole wall was caved in just minorly and it's bent this bar a little bit.
These are solid. These are like multi. See that? There's like 6 layers to the bus bar. They're thin pieces.
Oh, interesting.
Just so they can bend them.
Well, no, it's probably to handle DC. DC travels better in multi-strand than it does in solid core, right? So,
right.
Cool. Well, we're gonna go test this thing and see if it'll catch fire after it's been dropped, and let that be proof that at least the batteries and the cells themselves are protected in 1 inch in all directions from the rest of the case, so the case can take little 1 inch dents, no problem. And on this side here where the terminals are, you've got even more space, like 3 inches. So they could have even made this thing smaller, but it wouldn't have been quite so safe. Oh, let's get this, our little fireboard back in. I'm a big fan of cases that you can open up. I don't know how much water this little foam kind of door seal is really going to keep out. It'll keep out some moisture, but yeah, it's torn in the corners here from us removing it anyways. So it'd be nice to see something a little bit more robust than that. And they've got this great big lip that goes around. They could have probably put some better rubber seals in there or something that had a little bit more mechanical strength in the foam. But
to be fair to that corner, it could because the whole thing is
yeah,
shifted.
All right, let's get this thing into the boat. All right, we got it in here. Now, despite her huge size and huge capacity, this battery did actually fit in here pretty good. I think they made some really smart choices at Watt Cycle with designing the battery to be no wider than 2 batteries stacked next to each other, no taller, no one dimension that's out of proportion. So it kind of fit perfectly between 2 shelves. Now, I did have to take out a shelf to make it work, but as you can see, my freezer goes back into its slot, which which will eventually, of course, be actually trimmed in. Oh, sorry. Aaron's been fishing, so we had to fit a lot of fish in here. Oh, it's heavy. There we go. All right, and yeah, now the battery lives back there. And luckily, because it's got the Bluetooth module and a shunt built into it, and temperature sensitivity shutdowns and all of that stuff, I don't actually need to like access the battery hardly ever. Lithiums are pretty maintenance free. That is the idea of a BMS, or battery monitoring system. Now, this massive battery is heavy and it's huge, but if you really think about how many batteries this is replacing, 15 or 16 lead acid batteries fit in just the spot that 2 would have fit before. That's an incredible savings in both space, money, freaking weight, everything. I'm very excited about that. Do I need 628 amp hours of 12 volt? No, probably not. I was trying to do the calculations to see how long this would last. Now keep in mind, my main bank on this boat is 48 volt. So putting a large 12 volt only helps as my backup. So if my 48 volt battery goes down from overusage or some sort of glitch or some sort of problem with it, this will operate all the 12 volt systems. That's all the lights, the pumps, the bilge pumps, just every little tiny normal tiny boat system, but not the inverter and not a hybrid electric drive motor or anything like that. So by my calculations, I should get somewhere in the ballpark of 5 to 7 weeks of running this battery without charging it. Now that's running just like LED lights, fans, and pumps, but still that's pretty insane just for a 12 volt system. Now, I don't think everyone needs this, but if you've got 12 volt inverters, this would be a really good setup because you're capable of running a 3,500 watt inverter off of this with a 300 amp BMS. So that's an incredible amount of power. It's kind of an all-in-one battery. Like there's no way you need more power than this. You drop this into an RV or a boat and you've got enough power to live off of, really. That is just fine. So for me to have that as just a backup is insane. You don't have to commit all at once to a 628 amp hour, although it is a good deal, and I'll leave a link in the description. You can check it out. But they do sell 314 amp hour batteries, and they sell all the way down to the 8 amp hour battery, which we're going to go install in the dinghy now. All right, we've got the battery reinstalled. Bilge pump works. I've got my instruments working. My depth sounder here works good. And I've got a floodlight up front. So all of that could be run from this tiny little box with the battery built into it. I'm really stoked about. Oh my God. And then of course I've got voltage readouts right here on the display, but I can also log into the Victron charge controller that's inside this box. Now it's important, I think, every time you have any kind of lithium iron phosphate system, especially if it's off grid, if you're not going to go check on it very often, you really need to make sure you have a charge controller that can handle a 0 volt condition. And that means that if the battery completely depletes and it completely disconnects because of the BMS module, it's going to disconnect from your entire electrical system to protect those cells. Well, you need to be able to charge those cells back up, especially if it's running something important like a bilge pump. Now in the wintertime, maybe I might leave a searchlight on, or maybe I might leave this depth sounder going and I totally forget about it. Well, it's going to burn through the battery eventually, and then as it's raining and filling my boat with water, say I'm gone for like weeks on end off to sunny Thailand or something like that, I know that this will recharge and run that bilge pump and actually dry out my boat and that there's breakers and everything is all safe and good and I don't need to worry about it. So whether you're putting a tiny 8 amp hour battery or a huge 628 amp hour, you want to make sure you have that 0 volt condition and you want to make sure that everything is safe. For my review, I'll say I really like the plastic case that comes on the 8 amp hour battery. I like that it's epoxy coated terminals. I like that it's stainless ends. In a marine environment, that makes a ton of sense. And these tiny little batteries, you can pretty much guarantee anywhere you're going to install a tiny battery like that, it's probably going to be pretty close to nature. Now, the giant 628 amp hour, that's got a metal case. Now, the metal case is nice, and like I said, having all of that space around it meant that when it took an impact, when it took some damage, that battery is huge and heavy, and the shipping company probably dropped it at some point. It still held up just fine. So that's a big bonus point for them. Now, would a plastic case have held up? Probably not when the battery weighs 150 pounds. I think that probably would have cracked the case. So I get why it's a metal box. And for a lot of people, they much prefer the metal box. And for a lot of applications, especially if we're going to put a giant battery in, a metal box makes a lot of sense because it's going to be somewhere that's a bit more protected, a bit further away from the salt air. And it's still anodized and it's still painted and it's still like really nice, and there's no signs of rust on it or anything like that. So it's not like I'm just nitpicking here at this point. Anyway, very happy with the Watt Cycle. Thank you so much, Watt Cycle, for sending out those batteries. The link, as always, is in the description, and let's get back to setting myself up for proper off-grid. Now, as I mentioned before, the engine room has been modified a couple of times for a couple of different engines. Originally, this boat was launched with a 4-cylinder, or so the story goes, and then it was modified for the Volvo TMD40. Now, the TMD40 is also a 6-cylinder, so some of the beds are in similar locations, but it is a wider bore and shorter stroke, making it a higher revving engine than the Nissan I'm hoping to put in here. So not only is the Nissan skinnier, but it is also taller as a result. So a big part of my job here is to remove the previous equipment and also all of the holes and modifications that were made and cleaning this whole area up. I want to fair and sand this all out so that when I paint it, it is smooth and slick. Now the beds for the transmission mounts are going to be mostly fiberglass, but I need to put a hardwood in there as a filler to at least hold the shape before I glass it all up. So to hedge my bets, I've chopped and glued up some sapele and made sure that the grain ran sideways so that I don't have issues with rot running down the length of my engine mount. All right, so behind me you can see I've got engine bed here and here for the transmission. Now you'll notice they're a little bit too high. I just measured that out with the template I made, and the engine mounts are exactly 2.5 inches too high. And that's fine. I'm going to take it into the shop, but one of the things, because the hull and even these engine mounts aren't exactly perfect, this one ends a full 3/4 of an inch before this one does. So nothing is like perfect lined up. It doesn't really have to be. It has to be like as close as we can with a nice level. That's important. So we're going to put a stick on this, and we're just going to mark the 2.5 inch lower, and I might even go a little bit lower than that to give myself room to build back up. Now, that's always the way you want to do it with these beds. You want to make them a bit lower than they need to be, and then build back up to the right spot so that you can ensure that you're leveling out. It's way easier basically to like undo the nut and like raise the engine a tiny bit than it is to like dig the fiberglass out and sink the engine lower. So we're going to get this traced on. Before you give me trouble for using a level on a boat, I did change the trim of the boat significantly. So we're actually riding level for probably the first time in a long time. This boat is actually level right now. So this is basically as close as I can get using just levels with what I've got. Similar to an aluminum or a steel boat where you can just weld other pieces to it and get a functionally strong engineered chunk of your boat, the fiberglass boats can literally just be fiberglass too, and as long as you're using good quality glass and tabbing things properly, and in my case I always use epoxy, so I'm getting a really good adhesion, and this is going to be as strong as anything else. What I especially love about fiberglass is that it's such a low-tech solution. I really just need the materials. I don't need a ton of electricity or heat or anything else. I can just glue it in place and move on. A little bit of sanding, a little bit of fairing, a little bit more fiberglass, and so on and so on. It is just the most modular, easy to work on material, and I know that the dust is a pain in the butt, but honestly, after so much steel and metalwork and aluminum work I've done recently, I'm finding the fiberglass to be more enjoyable than ever. As far as engineering, I'm not really sure how much glass I need to put on here. All I know is that the previous engine beds have handled much more weight and have much less glass than I'm putting on now, and therefore I'm probably in the clear here.
Because I'm so cool and calm. Cool and calm. I want dust in all of my epoxy.
I may not be the world's best fiberglasser, but I'm certainly better at fiberglassing than I am at welding, and I'm just appreciating this going on so smoothly. I'm now using biaxial glass, which is new for me, and I'm really liking this stuff. That's it. We got engine mounts. I've got a plywood engine in there, and that's it. We gotta wait for all of this to dry, and then I gotta prep this actual engine room to be ready to put an engine back into it. And there's still plenty of fiberglass work, plenty of fairing, plenty of repairs from the old engine to do, plenty of rerouting. I want to change stuff about through hulls. Lots more to do still. We're not out of the woods yet, guys. As much as I really want that engine in there, there's just so much work still to do. But we'll get it done. Thank you guys so much for watching. Thank you so much to WattCycle for sending out the batteries in today's episode. If you want to check out the link in the description for that massive 628 amp hour. That is insane. And the little 8 amp hour though, I'm loving that thing so much. It's really nice to have power on my dinghy. The ability to not have to bail out my dinghy anymore is just chef's kiss. And the depth sounder I use constantly. Aaron likes it because it finds fish. Once I've had a bit more time to use it, I'll let you guys know how that panned out. But for now, I'll see you guys next Friday. Cheers.